we've got a large, variably shaped nucleus. The cell is strangely looks like a shamrock, and small cytoplasm relative to the nuclei. So you've got a whole bunch of nucleus and not much cytoplasm. So we got variation in the size and the shape, lots of the special features that allow the cell to function. This is the nerve cell. Disorganized arrangement. This is very arranged in a normal tissue. And here, this is just a scramble, like garbage. And then the poorly defined tumor boundary. So there are boundaries, and this is just going all over the place. It's spreading by extension into the tissue, and then it can break off and metastasize too. Okay, this is the part that's just got this is a whole bunch of stuff on this notes page. Sorry about that. It's not easy to read necessarily, but so what the doctor's going to look for, the pathologist is going to look for, is the regularly shaped dividing cells, and the nucleus varying in size and shape and being bigger than what a normal cell would have, and less cytoplasm in the cell. And loss of the features, loss of the normal tissue organization, and the tumor borders, or the cell borders. So, let's see. What we're going to make sure that we emphasize is what's the difference between both benign and malignant. So, benign tumor cells, even though they're not normally supposed to be there, the benign tumors have a specific morphology. Morphology means what? Shape. Size and shape. You know, when somebody morphs, they change their size and shape or their structure or whatever. Yeah. So morph, if you know what that means, is you know it's changed into something that it wasn't to begin with. All right, so the specific morphology, it's going to look like the parent cell and it is under DNA control. It's going to have the small nucleus of cytoplasm, those specific differentiated functions. It still knows what to do. It still can perform its differentiated function that it was told to do in with the cell, what came out the name? Stuff just flies out of my head sometimes. I start thinking way ahead, and I do that. The embryonic. I knew it started with an E. I see a big E in my head. Embryonic cell. So, the adherents, they do have the cohesiveness. They don't migrate. They're not invasive, but they can expand, though. If you've got a hyperplastic or hypertrophic, if you've got hyperplasia, if you've got more cells than you need, and it can sort of invade into the space, but it's not really invading. It's just extending because it is like a sort of a controlled growth, but it's an abnormal controlled growth. It's not the way it's supposed to be controlled. And then the orderly growth pattern, it's well-defined borders, and it is euploidy, which means how many chromosomes? Pairs. We have 23 pairs and 46 chromosomes, right? All right, so the cancer cells. We've got the rapid or continuous cell division. Now, sometimes some tissues grow faster than others when there's cancer, but they don't respond to signals for apoptosis. So the benign cells are mortal like normal cells would be, but the cancer cells do not respond to the programmed cell death, and that's they're just immortal. And have y'all ever heard of that the Immortal Life of Henrietta Lacks? Did y'all ever have to read that for school or anything? Have you heard of it? Okay, because it's really weird, but it's really fascinating, and it's so sad for her, but it's really amazing. So you ready? We're going to talk about that in 211. We have time, I'd love to, because it didn't be a lot. it's black and white, dramatic, and all that. It's a retro kind of movie. His name.
So the benign cells are mortal, they respond to the treatment.
Yes, they are mortal. Yeah, they are mortal. They can die. But if they're just pushing, if the tissue's growing, extending because of the hyperplasia or the hypertrophy, then you can still have damage, even though there's some cell death going on. So the anaplastic morphology, it doesn't look like the cell of origin. Like this is what a normal nerve cell looks like, and that's and I'll just roll it up. It's like a dead leaf or something. This is just like this garbage, horrible stuff. So it certainly doesn't look the same. And sometimes when pathologists are trying to decide what tissue it came from, they can't really even tell unless they do like chemical tests. I bet Julie would do that because she's looked around stuff a lot. But you have to put certain stains on it to even tell what kind of a cell it is. And sometimes they never do know where it came from. And so it may have started in the tissue where they found it, but it doesn't look at all like that tissue or any other tissue in the body. And they can't get the stains to work. Sometimes it's really of unknown origin. So, but now most of the time you can. So one of the things about cancers and looking to see about what the prognosis is and how to treat it is the differentiation level, because with my dad's liver cancer, his cells were well differentiated, and his liver function tests like the SGOT and SGPT and the LDH and those kind of things were somewhat elevated, but just a little bit, really. Not anything real dramatic, and there was not any. It was not positive for his alpha beta protein is sometimes a tumor marker, and it usually when you have hepatocellular cancer, you're going to have a high alpha beta protein level, and it was not, and so he has a well differentiated cancer, and that's a better prognosis. But if it's not differentiated, it's good to be well differentiated, but if it's poorly differentiated, that means it's not doing anything. It's just growing and damaging the other tissues and invading and taking over. So differentiation is a big deal. If it looks like the tissue of origin, that is a good thing. But it still could be invasive. Okay, so we got the large nucleus to cytoplasm ratio like embryonic cells. So that's that's a reason why I showed you that. Embryonic cells, that's the only time it's normal for you to have a large nucleus and more nucleus than cytoplasm. And so you've got, it loses some or all of its differentiated functions, like we said. All it knows how to do is divide, like the embryonic cells, right? So it's like going backwards. It's going back to the primitive cells that we started with when we were conceived, actually. So, and then we have that loose adherence. It's no fibronectin, like the embryonic cells. They're non-cohesive, and the biggest thing is that they do grow by invasion, and they don't stop at the tissue border. They have we need to build a wall, so we can make a border there. But sometimes the body tries to wall out cancer, but it doesn't always work. It can start developing enzymes that can break through and all that. It's really a treacherous kind of thing. So no contact inhibition. They don't not mind being close together in a limited space, just like the embryonic cells. And aneuploid. So we talked about euploidy, meaning we've got the 46 chromosomes or the 23 pairs of chromosomes. That EU means that's good. Well, aneuploid, that means it's not good. It doesn't say. I don't know why they don't have dis there instead of anu, but you've lost the normal chromosomes that you normally have. You might have enough chromosomes, but they may be damaged or they may be abnormal. So you could lose or gain chromosomes, like greater than 23 pairs or less than 23 pairs. And it could be an abnormality in the structure of the pair. Maybe one of them's normal and the other one's abnormal. They both could be abnormal. But anyway, it really means it's not normal in the structure of the chromosomes if it says it's equal. Okay, so now we're going to go into our loss of normal growth control. Yeah, that was a really long sheet, but it has a lot of explanation about how, because if you can compare it to the benign and to our baby cell, I think that's just the coolest thing. I'm so glad that they put that embryonic stuff in one of our textbooks that time, because I really like to keep that to get that concept, because I had never heard about it until I read it like that in that book. I'm like, oh wow, that's a really neat thing. We start off being kind of primitive, and then all of a sudden we're just very complex, and then the complexity disappears, and it's just a mess. Okay, so loss of normal growth control. Here's our normal divisions here, and then we've got a cell damaged, and there's no repair to it. And then, okay, cell suicide or apoptosis. So it's marked for destruction, and then the immune system gets rid of it. So, but a cancer cell division, it mutates even more. This is a cancer cell, and then you've got more and more and more, and then this whole mess with uncontrolled growth. So the loss of normal growth control, obviously, and the rate of new growth and the cell death is supposed to be in balance. We mentioned that before, but in cancer, it's way out of balance, and you can really tell that from those pictures. And so the apoptosis is cell suicide, where it can be targeted to blow up itself or tagged for the immune system to get it. And so it can self-destruct. But the cancer cells don't do that. They just want to keep on being immortal. And yeah, Henrietta Lacks is still immortal. And she died, when was it, 58 or 60 or something? It was way more. She's still got cells growing. And then cells in the same tumor can be at varying degrees of mutation, and that affects treatment. And what used to happen, I guess we're getting better at this, because there's so many signaling signals to growth and suppressors to growth and all in our cells, that we're just keep discovering all these MAB ending medications that you see advertised on television, sometimes that are, I know you see some for inflammatory conditions like RA and psoriasis and stuff, but they also have these cancer drugs that are targeted there, and that can really keep people stable. It may not kill the cells, but it may be able to keep things stable for a lot longer than we used to be able to. But the varying degrees of mutation, I know we had a patient that had a real aggressive prostate cancer, and he went to like a biological experimental hospital in Tennessee or something, just to try, because he all of the regular standard treatments just didn't work. That just didn't pan out at all. So he was still in pretty good shape. That his cancer was still growing, but he was still able to get and take care of himself and stuff like that. But he went down there, and they gave him an antibody. They made an antibody to his cancer cells, his prostate cancer cells, and infused it into his body, and it ended up killing the lining of his colon, and he had just raw. It was just absolutely raw, like you have a tremendous inflammatory bowel disease flare up. And so he almost died because of that. But what happens is that the cancer cells are in different stages of mutation. You see, it's a mess. They're not all alike. And that's the problem as far as just targeting a cell that's exactly like this, because not all the ones right like this are exactly the same in here. So you might kill some of them, but then if there's a little bit of crossover with mucous membrane tissue, that some of the cells in the mucous membranes were responding to the treatment, and they died, and so that the patient did not die from that treatment, but he was very sick for a long time. So that was a frustrating thing, kind of on the way to making better cancer treatments. I just have written this on my notes page in the Giddens first edition on page 94. It says there's more than one incorrect stop or go signal for cancer to occur. Lots of checks and balances need to be there to protect the body's system. And usually it takes multiple errors for healthy cells to turn malignant. So it's multifactorial. Usually cancer is not just from one thing, but there's multiple things there. You may just have been real sick with a bad infection or something, and your immune system's not real strong, and then you get exposed to something, some kind of chemical, a toxin or whatever, and then all those things are hitting you at one time. So anyway, I think that's a pretty good thing to talk about, or to realize, is that most cancers are multifactorial in causation. So, all right, this is our process of cancer development. Initiation, that's the first thing. The viruses, hormones, radiation, chemicals, hereditary factors, unknown factors can hit the cell. Maybe all of those are hitting them at once. They may have all of those things. And then you've got an altered cell, and then it starts not functioning, it's not differentiated like it was, and it starts to proliferate, and then it's a cancer, becomes a cancer cell, and a promoter helps the proliferation and increase the mitotic rate to make it increase in its production speed. And then progression is when you can actually see it. And with progression, gosh, you can have millions of cells in just your little finger, just a tumor that you might see on a scan. You don't really see tumors any smaller than the end of your little finger, or it's a little more iffy that way. So then you've got the evidence of regional spread and metastasis. So that's a sad thing. So just definitely remember on that notes page where it says initiation, and I've got it underlined and bolded and italics. It's an irreversible event, the permanent damage to the cellular DNA, and the proto-oncogenes. Remember we talked about proto-oncogenes making the embryonic cells divide. So proto-oncogenes get turned back on. They're not supposed to be acting anytime in your life except when you're an embryo. But they do turn back on in this situation. And it encourages the uncontrolled growth. So it was only normal for the embryonic cells. So there can be damage to genes that were not repaired or had a defective repair. Now, some people can actually have inherited cancers, or that you may have developed the abnormal cells in utero if the mom was exposed to something before birth. But that can change the baby's genes. It can change the mom's genes too, even after you're born. But anyway, suppressor genes get turned off, and then the genes that should stay quiet are turned on. So you can say the suppressors that allowed the differentiation process in the first place, it turned off the proto-oncogenes in the embryonic cells. They're supposed to, the suppressor genes are supposed to be active the whole rest of your life, but that's not what happens when the cancer comes up. That fails. That system fails, and then the proto-oncogenes are turned on or expressed. If the gene is turned on, then that means that you're expressing that gene. Okay, so the oncogenes, when they're turned on or expressed, they do cause the change from the normal cell to the cancer cell and promote the proliferation. So y'all heard of they call it BRCA1 and BRCA2, BRCA1 and BRCA2. What is that? What kind of cancer do you think of when you hear that? Did you hear about Angelina Jolie's deal and all that? She found out she had it, the gene, the BRCA genes. So what kind of cancer did she have? Breast, right. So, and that can have to do with like endometrial or ovarian, and sometimes even colorectal cancer. It is definitely a hereditary breast cancer in that situation. So, if those suppressor genes are turned on or expressed, then there's not as much immune surveillance. Our immune cells are oblivious to it, and so that's really scary. And so you're expressing your oncogenes, and especially if it's a stress time, just like what you said, some carcinogens or maybe people with AIDS. Have y'all taken care of people with AIDS that have cancer? Have you heard of that? But AIDS patients are very susceptible to cancer because of the immunity is really down, and so the surveillance is abnormal to begin with once they have the full-blown AIDS. And if you do have like a baby that's born without an intact immune system and it's not functioning, and have you heard like the boy in the bubble or the baby in the bubble or whatever, where they have to have a closed-in environment so that they don't get exposed to any infections and such. But since they don't have the immunity, they can have mutated cells that are not protected by their immune system, and they can end up having something, especially like lymphoma, and that's what you were talking about. I don't know if that's what the child was taking care of. Was it like a hereditary, or not hereditary, but were they born with it, or no? Okay, but we did have a child at Duke when I first got out of school. I worked on surgical floor, but I got to know a few of the people that worked on a research unit, and they had a child that was born with no immunity, and so they had a special bed for him and everything to keep him enclosed, and they take care of the gloves, and they could hold him, but they had to not really touch his skin and such. I don't know how they do that forever, but the mom was a teenager and just couldn't handle it and just deserted, and she just did not have anything to do with it. And so the nurses were just his mom, that whoever was taking care of him, and he lived for several years on that unit, and he had his crib and all this stuff, and all of a sudden, boom, he my left hand will do it, my right hand. Anyway, he just had this full-blown lymphoma, and couldn't overcome it, and he died. And those women those nurses were just like, it was the most awful thing, because they really were his mom, because nobody else was taking care of him. No relatives came in or anything. And so that's really one of those very hard things. That I think the best thing about nursing is developing relationships and positive relationships with your patients, and sometimes very loving relationships with your patients. I'm not saying them in a kind of any weird way or whatever, but you do just love people sometimes, don't you? I mean, you can't help it. And it's hard to develop boundaries. And if you've got too many boundaries, you don't need to be a nurse anyway. You wanna go overboard to do the best thing for that patient. But anyway, that was an extremely sad situation. The whole hospital was grieving about it, but especially those nurses that took care of him. That was just their baby. Anyway, so the tumor suppressor genes, they can be inactivated like if the chromosomes get messed up, a deletion or mutation in the chromosome can cause that to happen to where the tumor suppressor genes don't work, and that can be in the inherited cancers. And the very first one that I heard of as a suppressor gene is called P53, and it's associated with sarcoma and breast cancer and brain cancers. And so that when the tumor suppressor genes are not working, that's really, really, really bad news. So what we need to go to next, our next phase, is the promotion, the enhanced growth of the initiated cancer cell. You have to have initiation first that gives that first damage to the cell. And it could just be one thing, and it could be multiple things with the viruses, hormones, radiation, chemicals, hereditary factors, unknown factors. We just don't always even know what's made to happen. But anyway, you have to have a promoter to help to make the cells grow faster, to divide faster. So, is an initiated cell that's already had that irreversible damage. It has to be promoted, and it does not. After an initiated cell, if you don't have a promoter, it may not grow for a while, and then a promoter might come along at another time. But anyway, the initiation has to happen first, like alcohol and smoking, and they can act as the initiator. But if you continue to do it, it promotes it as well. Smoking is tobacco is an initiator and a promoter. It's like a weak initiator, but it's a strong promoter, and that's so some substances can really be both. They can be an initiator and the promoter. So then we do progression. We're going to be able to see the detectable tumor on scans and such, or if it's on the surface of the body. And so they're going to promote their own survival. And so what you can see is ectopic hormone production. What's ADH? You've got antidiuretic hormone. And okay, now who had the patient with the lung cancer? I can't remember. Who had the lung cancer with the inappropriate ADH? I can't remember which student that was.
Hillary. She's not here.
Oh, okay. But anyway, that inappropriate ADH, the patient had a low sodium and had to go on a fluid restriction, right? Okay, and what's ACTH? Yeah, adrenocorticotropic hormone. So there can be abnormalities in that where you end up developing a whole lot of edema. And then sometimes insulin is affected as well, especially if you got pancreatic cancer. You can really see some problems with that. And let's see, Christy had the patient with the pancreatitis, and I wonder if his repeated pancreatitis is what made him diabetic to need the insulin in the first place. Do you reckon? We don't know really what came first, do we? But the pancreatic cancer.
The alcohol would be my guess.
Right, yeah. But the inflammation of the pancreas might have prevented the beta cells from being able to secrete the insulin. I don't know. We don't really know who was the chicken or the egg. The alcohol was the chicken and the egg one. But anyway, with pancreatic cancer, you can have problems with insulin production, and so you have to go on insulin. And then parathyroid hormone can mess with your calcium. So angiogenesis, have you heard of that before? What's genesis? So you're creating something. What do you think angio has to do with? Blood vessels. So the tumor creates its own blood supply and actually helps to initiate extra blood vessels. Like when you're needing healing and extra blood to come to the tissues, if it's like especially a long-term healing, the new blood vessels can develop in that area so that you can get nutrients to it and everything. Well, tumors can develop those chemicals to help to make them survive by developing their own blood vessels. So angiogenesis is something that's just one of those wicked things that it does. And then, so what's going to happen to the nutrients in the bloodstream if the tumor develops a blood supply? So the tumor is going to get fed, and the rest of the body is not, right? So that's why some people just they call it cachexia, where you just like you've been in a concentration camp for 5 years or something, and they don't feed you or whatever. Yeah, it's just it can starve the patient but feed the tumor. So that's not a good thing. And then vascular permeability. So the tumor can develop enzymes that can destroy the membranes between cells and tissues, and that they can invade into the tissues that way, and they can do it just in the tissue area, but then they can make holes in the blood vessels to be able to easily let tumor cells break off and go over the rest of the body. And it can be through lymph channels or blood channels. So they do that lysing. You know, we keep talking about lice, and when we have ASE at the end of a word, that it means what? That it's an enzyme, right? So enzymes lyse the tissue, blood in the lymph vessels and normal tissues. Okay, so then the next thing is the metastasis. And I think I was telling Shelby this a while ago. My desk was just a nightmare, and I just piled up stuff and dumped it on a shelf. But Dr. Black used to tell me that I metastasize everywhere I go, so I spread my stuff out, and it just stays there. But I know where stuff is, though. That's the thing. I'm really messy and cluttering, but my husband hates it. But anyway, yeah, I metastasize everywhere. Where did I go? Papers and mess. Okay, so it extends into the surrounding tissues. And blood vessel penetration is what's going on. Release of the tumor cells and invasion and overtaking the invasion in the adjacent tissue and breaking off and moving into other places. So that is metastasis. So, one of the things that can happen also is local seeding. You'll explain about it. Tell us about that. Yeah.
When I was researching the abdominal perineal resection, I learned that if they disturb a tumor, part of those cells can land elsewhere in the cavity that they're messing with. So they have 3 different ways that they try and prevent that. They can't really prove it helps, but it can't hurt. They can do a warm saline wash, an antibiotic, cavity wash, or a chemotherapeutic wash, which that one can be dangerous because it's really hot and it can burn other organs. But during my surgery, I had asked the surgeon about that, so he added a saline wash to help this guy because they weren't able to remove the whole tumor to hopefully keep it from spreading.
Yeah, and if you've got instruments that have cut into an area of tumor, people used to just just use them again. Oh, it's still sterile, but now they pay attention to that, don't they? They change they get a new one. They discard the one and then they get a new one. You probably saw a lot of that change in instruments.
Especially with them cutting into the bowel, they had 3 sets of instruments they had to go through.
3 sets, wow.
Mm-hmm. They weren't ready to tell him yet till they did another scan, but they weren't able to get it. It's because they called it a R1 because it had moved into the abdominal wall and they carved into it, but they couldn't reach it all.
Mm. So he's going to have to have
and he doesn't know it yet.
Multi-therapies and everything to get that straightened out. But that's just so. It's not cool for the guy, but it's so cool that you know this and that was and the doctor didn't do that until you said something about it, did he? Was he?
Because he told me he wasn't planning on it, and we were just asking questions.
So cool.
And he's like, a lot of people come up with new methods, but they can't prove them because hindsight's 20/20. And so he's like, well, it can't hurt. So he requested them to bring in warm saline to do it.
I think that is so cool. So you influence some. Like you said, it can't hurt, so why not? Yeah, I think she deserves a hand. Boy, she was into that thing.
That was awesome surgery.
Ms. Walker said you were the next week too. Oh boy, yeah, that's where you want to be. I can take it. Yeah. All right. Well, thank you. So, bloodborne metastasis. This is something you gotta remember. That's the most common way that cancers are spread to other organs that can be. Like sometimes if it's just spreading into adjacent tissue, that's not going to kill you. But if it goes to a vital organ, it certainly can. So, that just remember that that's the most common cause of the cancer spread is the bloodborne metastasis. And there's only about 1 in 1,000 cells that escapes immune detection if you have an intact immune system. But a tumor the size of the end of your little finger, like 1 centimeter, can have about 10 billion cancer cells. I've seen different numbers here. 10 billion cancer cells. I said millions a while ago, but 10 billion, that's tremendous. What's that? Yeah, I've read different things, because that one said 10, well, billions a whole lot anyway. At least we know it's loads and loads, yeah. Yeah, I guess I thought I had seen some 10 millions too. That's a whole lot. Impaired immunity is definitely one of the major roles in the development of the metastasis. Okay, so lymphatic spread also is it's like one of the second ones, and you can get into lymph nodes. And I think y'all got into lymph nodes, didn't you? With the surgery, they checked the lymph nodes. Did y'all see anybody else with an OR saw lymph nodes removed?
They said he had more in that area than they expected, so it makes me wonder if that was his body's way of fighting, or
it might have been. Yeah, because your immune system wants to just sequester that and not let it go somewhere else, and the lymph nodes can get large, but they can break through. What kind of surgery did you see? Oh, that was long. Wow, there are loads of lymph nodes in your chest, or in that thoracic cavity. So yeah, okay. So the most common sites of metastasis is lymph nodes, liver, lungs, bones, and brain. And let's see, 50 to 60% of all cancers are metastasized before they even know about the primary tumor. Okay. So there's interference in the DNA to cause the cellular mutation. So this is one of the biggie concepts here too. All cancers have mutations in the genes. That does not mean the genes that you were born with, though. Your genes can become damaged in your life as a non-fetus, I should say. So it is not necessarily something that you were born with or something that's hereditary. If other kinds of things, chemicals and even hormones and things can mess with your genes. So it can be inherited or environmental. So you could have initiation, promotion, or progression, and the genes can be altered in any of those phases. And we have oncogenes that promote the proto-oncogenes for the ones with the embryonic, that there are oncogenes as well, and our tumor suppressor genes, we've already talked about that. And then carcinogens are the causes, the initiators. So, I think I'll just do this page and we'll stop because it's getting long here, isn't it? Anyway, we have carcinogenesis. We talked about the genesis already, right? The creation of the cancer. And it's also called oncogenesis. This oncology is the word for cancer. So we've already said that it can certainly be multifactorial. Your immune system has let something escape, or more cells escape than they normally would, and then you've got other stressors on your body. So the damaged DNA is what starts the process. So that's something to remember, that all cancers have to do with problems with the gene, whether they're born with it or whether it happens later on. So mutations in the genes. Okay. So carcinogens. What are they? That's what starts it up, isn't it? Yep, the substance that changes genetic activity in the cell, so it can become cancer. All right, causes the mutations in the cellular DNA. All right, so we got external ones can be the chemicals, radiation, viruses, drugs. Internal can be hormones, immune problems, and inherited mutations. So that it can be internal or external. They can act together sequentially, or whatever, to initiate that or promote the carcinogenesis. So all of those things can be. We'll give some specific examples in a little bit or tomorrow. It might take 10 or more years between the original mutations and which is the initiation and then the detectable cancer. Kind of depends on whether you have a promoter immediately or not. So if there's initiator and then the promotion doesn't happen until later, it can take longer. Sometimes it just slowly promotes, especially if it's a slow growing kind of tissue. So anyway, promoter substances cause the toxicity to the cells, hormonal imbalances, and then decreased immunity, chronic tissue damage. All of those kinds of things can be toxic to the cells. So everybody comes into contact with the carcinogens. But we do every day, don't we? Up to reach it outdoors, and you got like asphalt being poured and people working and all that kind of stuff. And we're around a lot of chemicals too, aren't we? And that's one of the things that I tell students sometimes, that you can put gloves on at any point when you're preparing medications. If you're draw something up, and sometimes it'll drip on you, and it could affect your skin. We don't really know. We can't really ethically do an experiment on something like that because we don't want to hurt somebody. But if you want to really protect your skin, especially if you're blowing up a liquid, so to wear gloves, because it can spew out and get on your hands. Yeah, you can wash it off, but over and over and over, year after year after year after year, you don't know what that might do to your skin. I think that's why I've got weird thumbs. They just never get soft anymore. But okay, so there are some viruses that can cause the hyperplasia, and that can be related to certain types of cancer. The hyperplasia can evolve into cancer. And most people's bodies can suppress the progression to the malignant cells, but that just doesn't always happen. You don't really have to know which viruses. I don't know if it has lists. Remember that list of different viruses. You don't have to memorize those, but just know that there are some viruses that can cause specific cancers, and especially do remember the HPV. What does HPV lead to?
Cervical cancer.
Cervical, and what else?
Uterine, ovarian, throat, and neck.
What's that?
Uterine, ovarian, throat, or neck.
Yeah, uterine, ovarian, throat, or neck. What else?
Anal, rectal, and neck cancers.
Anal, yeah. Okay. All right. So, yeah, it is. Anal and penile, yes. And that's, with there's a lot, evidently more oral sex than what we do. We've got a real, not epidemic, but we're seeing more head and neck cancers caused by HPV because of oral sex than the cancers from alcohol and smoking. And that is usually a squamous cell. And if you've got like a stage 4 squamous cell cancer, it's like curtains. You're not gonna live through that. But like Michael Douglas admitted that he really thought that he got HPV through oral sex, and he ended up, he was in stage 4, and I thought, oh, okay, he's a goner. But no, before that came out, he was fine. I mean, he's really doing well. He looked really terrible for a while. He probably had to have radiation and really awful chemo and stuff, but he looks looks good now, and I've never seen stage 4 head and neck cancer survive like that, but you can with the HPV type, and that doesn't mean you want to get that kind, but it is much more treatable, and you can get a total response. So, yeah, I had looked online. See, okay, let's stop on that one, and then we'll go to the next.
They said it's one of those ones that they can